Hi everyone, my name is Bharti Chaudhary and today we are going to discuss question number 9 and 10 of the graded assignment sheet of week 1. So question number 9 says that if an M and N are true set, U is a universal set, phi denotes an empty set, and M intersection universal set union N union phi is equal to M union phi intersection N whole over intersection N union N, then which of the following statements are true? Let's first of all simplify both of the hand side and let's see what result we are going to get. So in the left hand side we have M intersection union of N union of phi. Let's simplify this one. First one, that is M intersection of universal set. Suppose this is my universal set U. To solve these kind of problem, it's better that you make Venn diagram. It will be much more easy to understand, and it will develop a concept which is unforgettable, right? Rather you will be remembering the facts. It will be very helpful if you make the Venn diagram. So this is my M set here. If you intersect these both of this set, you are going to find out the result is this yellow one, and this yellow is nothing but your M. So intersection with the universal set, this is going to be M, and the between between union sign will be here, and N union of phi will be N itself, right? So we have simplified my left hand side and this is going to give me M union of N. Let's simplify the right hand side now. This is going to be, here it is written M union phi intersection M intersection N union N. So we know that when we take union with an empty set, the same set is obtained. So M will be here. Now this can be written as M intersection of M, and with the intersection of N union N, it is nothing but N. Now M intersection N is M, and with the intersection of N. So left hand side is M union N and the right hand side is M intersection N. So by this you can say we have M union N is equal to M intersection N. So by using this relation we will be seeing that which of the following statements satisfy this result. So the first statement is here M or N will be empty set. So let us consider that my N is an empty set but my N is not an empty set, right? So I have considered my M is equal to 5. Let's substitute the result in this relation. This is going to be phi union N, which is equal to phi intersection N. If you remember the assumption, I said that I have considered M is equal to 5, but I have considered my N is not equal to 5. So phi union of N is going to be N and phi intersection with N is going to be equal to 5. So whatever the assumption that we have taken is wrong. Hence we can say that M or N cannot be empty. For being this result to be true, if my both of the set would be empty, if it has been written like this, M and N are empty set, that would be a true result here. It would be written like this, that M is equal to phi and N is equal to phi, then definitely this relation would be true and our option would be correct. But here in the question it is said that M or N is empty set. So we have already seen when we assume that the result or the assumption is coming. Not true. That's why option A is incorrect. Moving on to option B, it is saying that your m is equal to n. Fine. So this is the result that we have to prove that my set m is equal to set n. So let's prove this. Now we already said that we have m union n is equal to m intersection n. So what we are going to do, let us consider an element x from m. So I have considered x from my m. If this is present in m, it will imply that x is also the element of m union n. Because definitely if it is present in m, so it will be present in m union n. And as we know that, but we also know that we have considered m union of n is equal to m intersection of n. So we can replace m union of n with m intersection of n. If this is present in the intersection of m and n, I can conclude that x will be the element of n. From here, I can say that m is the subset of n. In the same manner, let us consider another element y which is present in m, which implies that y will be the element of m union n, and this will imply that y will be also element of m intersection of n. As we have considered that if y will be the element of n, definitely it will be the in the set of m union n, and as we know that m union n is equal to m intersection n, so we have got this result. Hence from here we can conclude that y is also the element in your n. From here we can consider n is the subset of n. Now by using result 1 and result 2, we can conclude that m is equal to n. Hence our option B is correct. Moving on to option C, it says that the cardinality of m minus n is 0. As we have seen that with this result we have come upon to this one, that m is equal to n. If I subtract m from m, the result that I am going to get is 5. And we know that the cardinality of empty set is 0, hence your option C is also correct. Let us consider option D. Option D says that m is a proper subset of m. If you remember, just now we proved that m is equal to n, and for proving m is equal to n, we saw that in between we considered that m is the subset of n and n is the subset of n. So as we have already known that your n is the subset of m, it means all the elements of n is present in m and all the element of m is present in n. That's why they are subset. So n is a proper subset of n will not be true. Why? Because according to this statement, there will be existing some element which will be there in m which will not be in m. That's why this option D is incorrect. Hence the correct options are your B and C. Moving ahead to the next question. Question number 10 says that the product of the minimum value of the function f of x is equal to 5 mod x plus 8, and the maximum value of the function gx is equal to 12 minus mod x plus 5 is. So I have to find out the product of these two values. Let's first of all find out the minimum value of f of x is equal to 5 mod x plus 8. I have to find out the minimum value of f of x. So I am interested in finding out the minimum of f of x. Now just remember that this is mod x. So whatever the value of x you are going to put, this is going to give you the positive result. So now what should be the what should I do that this should be minimum? Because definitely x is the variable, this part will be only changing. So I have to minimize my f mod of x. Now for doing this, when I tend my x towards 0, it means when my x will be tending towards 0, then I will be getting the minimal value of f mod x. Then my f mod x will be tending to 0. Thus, at x is equal to 0, I am going to get the minimum value, and the minimum value that I will be obtaining will be equal to a. Right? Now, let's find out the maximum value. Gx is equal to 12 minus 5 plus x. Now, this quantity is getting subtracted for 12 and we have to find out the maximum. So, for making out this maximum, definitely this should we have the minimal value. Now, when this will be minimal value, when this will be tending towards a 0, because this cannot tend toward any negative number because mod is there. So what is the lowest in all the positive value? It's 0. So definitely mod 5 plus x must be tending to 0. So to make or to get the maximum value. So when my x will be tending towards minus 5, then only I will be getting that my mod of f5 plus x will be tending towards 0. So my maximum value of gx will be equal to 12. Now in the question it is asking the product of maximum and the minimum value. So just multiply both of them, that is 12 into 8. You will be getting the result as 96. I hope I have made this question very clear. If still any doubt persists, you can ask me in the comment section below, or if you have got any different answer, then also you can write down in the comment section. I will be definitely looking into it. You can also follow me on Instagram and you can contact me on the mail ID which is given in the description below. Thank you so much, and we will be meeting soon with the next video.